Hi everybody. We have met in the last session of maths demo class. Hope you remember that. Today we are going to start with the demo class of FEEE subject. In this subject actually, we'll be studying about the fundamentals of electrical as well as electronics. We start with the idea of electricity, developing that, and we lead to the electronic field. So let's start with the basic idea about the electricity. Fine guys, what do you mean by electrical energy? Or what do you mean by electricity? Or what do you mean by electric current? Electrical energy. What do you mean by electrical energy? It is the energy possessed by the movement of electrical charges. The energy caused by the movement of electrical charges. What are electrical charges? It's nothing but electrons. So, electrical energy. Look at the definition of the electric energy here. Electrical energy is the caused by moving the electric charges called the electrons. Fine then. Now let's see what are the sources of electrical energy. From where you are getting the electricity? Of course, in our daily life, at our residences, in the complexes and in the apartments, everywhere we are getting the electricity. Guys, imagine the life without electricity. We can't imagine also. It's a basic part of our daily life. It's the basic part of our daily needs. We need the electricity. But where it is generated, where it is produced, from where you are getting the electrical energy. So that we have to study under what's called as the sources of electricity. What are the different sources of electricity? What are the sources of electricity? Actually, there are two different types of sources of electricity. What are the two different types of sources of electricity? First one is called as renewable resources. The second one is called as non-renewable resources. Renewable and non-renewable resources. What is the difference between that? And what are the different types of renewable resources and non-renewable resources? Fine. Let's go for the first type, that is renewable resources. Second one is non-renewable resources. Let's focus on now what's called as renewable resources. Renewable resources are one which never ends at all. Continuously it will be giving the energy. What do you mean by electric energy? It's nothing but one type of energy. Electric energy is nothing but it's one type of energy. As you know the basic concept, energy can neither be created nor be destroyed. Energy can neither be created nor destroyed. We cannot create the energy. We cannot generate the energy. But still then we say that electricity is generated. Can it be generated by itself? No. It can be generated at the cost of some other type of energy. What do you mean by that? Mechanical energy can be converted into electrical energy. Heat energy can be converted into electrical energy. Nuclear energy can be converted into electrical energy. So, to get the electrical energy, you need some other kind of energy. If the energy is a continuous supply one, and we are getting it converted into electrical energy, that we call it as renewable resources. Very simple example, solar energy. We are getting the energy, that is the heat energy from the sun. Continuously we are getting that energy. We are getting the energy continuously from the sun. How the energy is produced? How we are getting that in the sun itself? How we are getting the continuous energy from the sun? So there actually radioactive reaction takes place continuously inside the sun. Since so many years we are getting the energy continuously. But how it is possible? From where that energy is coming inside the sun, that is radioactive reaction. Inside the sun, the nuclear fission phenomenon takes place. During the nuclear fission phenomenon, enormous amount of energy gets released. So this is a continuous process inside the sun. As a result, that enormous amount of energy, a part of that we are also receiving on the earth. A part of that energy continuously we are receiving on the earth. So that solar energy, what you call the energy received from the sun, it is received by the photocells. Photocell will convert that energy into heat energy. Solar energy is converted into heat energy, and heat is converted into steam, and from that steam we are getting the electrical energy. One common thing is there. If you want to get the electrical energy, right? So there actually we need one form of energy. Usually for the rotation of the turbines, we need that. For the rotation of the turbines, we need that steam energy. So when the turbines rotate with a proper coupling to the motor, we are getting the electricity. That's common in all the electricity generating plants. Solar energy. Nowadays we are getting solar lamps, solar street lights. Everywhere that photocell is used, which converts the solar energy into electrical energy. Fine guys, look at this. Solar energy. Solar panels capture the sunlight and convert it directly into the electricity using the photocells. This is one type of what is called as renewable resources. Fine then. Let's go for another renewable resource. Wind energy. You might have seen the very big tower where at the top the fans are fitted. That is nothing but your windmill. What happens there actually? Natural energy. Wind is blowing with very high energy. So when that energy falls on the turbines of that windmill, the turbine starts rotating. That will be converted into electrical energy. That means in the windmill actually, the kinetic energy of the wind that is converted into electrical energy. So this is also what you call it as renewable energy. Continuously, as long as there is the wind blow, so we are getting this energy. Wind turbines convert the kinetic energy of the wind into electricity or electrical energy, you can say. Now let's go for another type of renewable energy, that is hydroelectric energy. What do you mean by hydroelectric energy? We are getting the electricity by the energy present in the flowing water. You might have heard the joke falls. So electricity generating station is joke. So there actually water is flowing at a very high point and it falls. At the bottom the turbines are kept. When the water is at a high point, since it is at a high point, due to that height, it has got the potential energy in it. Since the water is flowing with certain velocity, it has got the kinetic energy. So both type of energies are present in the water flow. When it falls down, the height decreases. The height decreases. The height means the potential energy decreases. But what about that potential energy which is decreased? So that is converted into kinetic energy, because when a body falls freely under gravity, gradually its velocity increases. So kinetic energy increases during the fall, the potential energy decreases. But at the bottom, the total energy will remain same. Whatever the total energy at the top, the same will be the total energy at the bottom. When that kinetic energy, it falls on the turbines. At the bottom of the joke falls. So the turbine starts rotating, which generates the electricity. That's called as hydroelectric energy. Look at this. The energy from the flowing water is used to turn the turbines to generate electricity. This is also a continuous one. Renewable resources of electricity. Alright. Geothermal energy. Next one is the geothermal. The heat present inside the earth. The heat energy present within the earth. So that heat energy, it is converted into steam energy, and that steam is used to rotate the turbines. So that is called as geothermal energy. Look at this. This uses the heat from beneath the earth's surface to produce the steam which turns the turbines to generate electricity. This is also a continuous supply of energy. Renewable resources. Will it be all right? Now let's go for biomass energy. What do you mean by biomass energy? The energy present in the gas, coal, oil, So that energy can be converted into what's called as electric energy. Just take an example of your thermal plant. Where actually coal is used, it's burned. We'll get the heat energy that is converted into steam, and that steam is used to rotate the turbines to produce the electricity. Joe Falls Hydroelectricity Generating Station, Raichur Thermal Electricity Generating Station, that is also called a thermal plant, and nuclear plant. So that is in Kaiga, near Karwar. Nuclear plant. So what was that? Nuclear energy, what I told you, nuclear fission process in the sun. And here in the nuclear plant, nuclear fusion process takes place. Fission means a heavy element, nucleus of the heavy element, uranium, thorium and all, it is split into two parts, that is called as fission. During the nuclear fission, a large amount of energy is produced in the sun, whereas in the nuclear power plant, it works on the principle of nuclear fusion. What do you mean by nuclear fusion? Two lighter nuclei are combined together, which are fused together to produce a larger nucleus. But during that process, due to the mass defect, enormous amount of energy gets released. So that nuclear energy, it is converted and used to rotate the turbines to produce the electricity. So that we call it as biomass and the nuclear plants. In the biomass energy, organic materials like wood, agriculture crops and animal waste are burned and processed to produce the electricity. Right? Let's go for non-renewable resources. What all we have come across? Solar energy and everything. So that is nothing but the renewable. Now we have to go for non-renewable resources which last for a short duration. The non-renewable resources, they are for a short duration. That's why the generation of electricity is also for a short duration. So what are the different types of non-renewable resources? Look at this. The resources for generating the electricity are those that are finite, restricted. They won't last for a longer time. Finite and can be depleted over time. Since they cannot run for a longer time, we call it as non-renewable resources of energy. Let's go for the examples here. Fossil fuels. Fossil fuels, just now I told you, maybe your coal, maybe the oil, maybe the gas. It's a supply of this energy is for a limited period, but that can be converted into electricity, but for a short duration. That's why it is called as non-renewable. These include coal, oil or natural gas. When burned in the power plants produce heat. That heat will generate the steam. Steam will turn the turbines. Heat, in turn steam, in turn rotation of the turbines. So that produces the electricity. Fine then. Nuclear energy, just now I have explained in the Kaiga plant. The energy released due to the nuclear fusion, so that is used to produce the heat, then steam, and then to rotate the turbines to generate the electricity. Fine guys, here. In nuclear power plants, due to the nuclear fission, large amount of heat is released. This is used to produce the steam to turn the turbines to generate the electricity. So these are the non-renewable resources. Fine. Now you know what is meant by electrical energy. We know what is meant by the sources of electrical energy. What are the different sources of energy? Now we shall see what is meant by electrical current. You know what's meant by electrical current. It is a continuous flow of charges. Which charge? Electron. What is the charge of the electron? It's negative charge. The continuous flow of charges, we call it as electricity. When the electric charges continuously flow in a conductor, that produces the electric current, we can say. Right? Is the flow of electric charge through a conductor. Fine. What do you mean by resistance? There are certain conductors which allow only a small amount of current to flow through that. There are certain conductors which allow a larger amount of current to flow through that. So, the flow of current in a conductor, it depends on the resistance of the material. Now, what do you mean by resistance? That is the opposition. The general meaning, resistance is the opposition. Suppose you have a conductor here. It's a metallic conductor. Maybe copper, aluminum, tungsten, whatever it is. So when the current pass through this, current means the electron has to pass through this. When the electrons are passing through that, then the particles of the material will offer the resistance for the flow of electrons to that. So whatever the opposition that is offered by the material, that itself we call it as the resistance. Greater the opposition, less will be the current flow. Suppose the opposition is less, then easily electrons can flow, large number of electrons can flow, which leads to higher strength of the current. Lesser the resistance, more will be the current. Greater the resistance, lesser will be the current. So what do you mean by resistance then? Is the opposition offered by the material for the flow of current. Fine. Just take a simple circuit here. Circuit showing the basic components. In this circuit, what are the different components present here? Source of energy. To drive the current in a circuit, to take the energy, there should be a source of energy. Correct? So which is the source of energy here? Battery. Look at the symbol that is denoted here. This indicates a battery, that is the source of energy. Of course, it is finite, non-renewable, remember? So this is a source of energy. When it is connected between the ends of a conductor, so this is a conductor whose resistance is R, then the current starts flowing through this resistance. When the current flows through the resistance, there is the loss of energy because the resistance offers. So this is a conductor which offers the resistance for the flow of current. So when the electron has to pass through that conductor, when the electron starts from here, it is more energetic. But it has to pass through the conductor, it has to fight with the opposition, and it has to overcome that opposition, and it has to come out from the other end. For that, some amount of energy is used. Certain amount of energy is used, right? So that energy, it appears in the form of loss of energy across the resistor. Whatever the energy of the electron is used in passing through this, in overcoming the opposition, that appears in the form of loss of energy or the potential difference. How will you measure the potential difference across the resistor? Using a device, voltmeter. How will you measure the strength of the current that is flowing or that is drawn from the source here, battery? That is called as ammeter. Ammeter is a device used to measure the current, and voltmeter is a device used to measure the potential difference. So this is a simple closed circuit. How to connect the ammeter? Battery positive should be connected to ammeter positive. Battery positive should be connected to voltmeter positive. Next, battery negative to voltmeter negative, and battery negative to ammeter negative. This is the way how the devices are connected in the circuit. Will be alright? One more important point here. If you want to measure the strength of the current which is flowing through this, so in that closed path, whatever the current is flowing, if you want to measure that, ammeter should be always connected in series. So if you want to measure the current, the same current has to pass through the ammeter. So it is connected always in series. Whereas the voltmeter, what is the energy loss across the resistor? What is the potential drop across the resistor? So voltmeter should be connected across this. Voltmeter, always the parallel connection, and ammeter is always in the series connection. Will be alright? This is about the very simple DC circuit. DC is used here. Now let's go for the relation between the voltage, current, and the resistance. We are studying about the basic of electricity, right? So what is the relation between voltage, current, and resistance? A certain relation is established by the scientist whose name is Ohm, and the law is called as Ohm's law. What the Ohm's law says? The current flowing through a conductor, it is directly proportional to the potential difference, or the potential difference across the resistor, it is directly proportional to current. So that is your Ohm's law. So the potential difference one minute, it is directly proportional to current. So this is your Ohm's law. Potential difference across the resistance is directly proportional to current. Suppose if we remove the proportionality sign, a constant of proportionality is used, and here we call it as R. V equal to R into I. This is the constant of proportionality. And here this R is called as the resistance of the material. This is the simple law, what is called as Ohm's law, right? Even you can take it as I proportional to V also. You can take it as I proportional to V also. Look at the screen now. This is your Ohm's law. The current flowing through a conductor, it is directly proportional to the potential difference V between the ends of the conductor. But this is important at constant temperature. That is the condition which we have to apply for the Ohm's law. If the temperature varies, then Ohm's law cannot be applied. So Ohm's law is applied only at constant temperature. Will be all right? Let's go for the mathematical relation here. Look at this. I is proportional to V or V is proportional to I. That's V equal to Ri, where R is the constant of proportionality and known as the resistance of the conductor. That I already explained to you. Look at this simple circuit. Look at the simple circuit here. So in this circuit, in the previous circuit, what I have shown, only one resistance was used. Whereas here, three resistances are used, and this is the power supply. But how is the connection here? When the components are connected in a circuit, there are two different types of connection. One is called as the series connection, and the second one is called as the parallel connection. Look at this circuit. So the three resistors R1, R2, and R3, they are connected end to end, one after the other. When the end-to-end connection is there, so that we call it as the series connection. So across this battery, this is the positive terminal, this is the negative terminal. Across this battery, three resistors are connected in series. When the three resistors are connected in series, the current flowing through all the three resistors will be same. The current never get divided in series. Remember, current never get divided in series connection. The same amount of current flows through all the three because there is no other way, no other path to get branched for the current. Is that clear? So the current in a series connection is same. But what is different here? The potential difference. This is the energy supplied by the source. That is called as EMF of the battery. Suppose if it is 12 volts battery, that 12 volts, it is split into three parts. When the current flows through this resistance, depending on the resistance, the potential drop takes place. Depending on the resistance value, potential drop takes place. Depending on the resistance value, the potential drop takes place. The potential difference across R1 is V1, that of R2 is V2, that of R3 is V3. So the total voltage V is the sum of all the three voltages. Remember, in the series connection, the current remains same, but the potential difference or voltage gets divided. Is that clear? Well then, let's go for the next connection here. Note the point what I discussed now. When a number of resistances R1, R2, R3 are connected in series, then what is the total resistance in the circuit? In the series connection, when a number of resistors are connected in series, the total resistance present in the circuit, that is also called as effective resistance. How will you find that effective resistance? That is the sum of the individual resistances. Effective resistance, if you write it as capital R, that's equal to R1 plus R2 plus R3. So this is actually what is called as the effective resistance or total resistance of the circuit. The equivalent or the effective resistance is R equal to R1 plus R2 plus R3 plus any number of resistances. Will be alright? Fine then. Let's go for the next type of connection that is called as parallel connection. Look at this circuit. Previously, there were three resistors, they were connected in series. Here, we have got three resistances, they are connected in parallel between the same. This is the positive terminal, this is the negative terminal. Across the same three resistors are connected. This is called as parallel connection. What is the important point to be noted here? Current starts from here, right? This is the direction of current. It comes to this particular point. When it reaches here, it has got three different paths. It has got three different ways. So current gets split here. I1 through R1, I2 to R2, and I3 to R3. I1, I2, and I3. The strength of these three currents, that depends on the resistance value. Suppose R2 is a high resistance, This R2, then I2 is smaller. More the resistance, lesser will be the current. Will be alright. But even though the main current is divided into three parts, the total current is always equal to sum of the three currents. I equal to, in this case, I total current equal to I1 plus I2 plus I3. Whereas in the previous case, the total voltage V equal to V1 plus V2 plus V3, whereas here total current I equal to I1 plus I2 plus I3. I will compare both now. In the series connection, current is constant, whereas in the parallel connection, voltage is constant across all the three. Second point, in the series connection, potential difference, voltage gets divided, whereas in the parallel connection, currents get divided. Remember, question may be asked in any of the point. Remember, from any corner you can expect the question in DCET. From any corner. So you have to pick each and every corner of the syllabus. It may be a question in the surface level, or it may be a question in the deeper level. These are the expected questions. The question may be like this. In the series connection, dash gets divided. Voltage gets divided. You are select voltage. In the parallel connection, dash gets divided. Current gets divided. In the series connection, that remains constant. Current remains constant. In the parallel connection, dash remains constant. Voltage remains constant. So in any manner, you can expect the question in the DCET. Fine, guys. This is about the, what do you call it as parallel connection? Fine. In the parallel connection itself, suppose if you want to find the equivalent resistance, just make a note of it. In the series connection, R equal to R1 plus R2 plus R3, right? And plus dash dash dash. Whereas in the parallel connection, the effective resistance, it is written in the reciprocal form, 1 upon R. 1 upon R it is. So 1 upon, or the reciprocal of the effective resistance, is the sum of the reciprocals of individual resistances. 1 upon R2 plus 1 upon R3 and so on. Series connection, effective resistance is sum of the resistances. In the parallel connection, reciprocal of the effective resistance is the sum of the reciprocals of the individual resistances. Idea is clear. So this is about DC parallel circuit. Fine. Let's go for the next point here. When a number of resistors are connected in parallel, then what is the formula to be used? 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. This is about the simple series and parallel circuits. Now let's go for the types of energy sources, electrical energy sources. We have come across the electrical energy sources for renewable and non-renewable. Now, electricity is generated. We are getting the electric energy. There are two different types of electric energies. Alternating current and direct current. AC and DC. Let's just study about the comparison of AC and DC. What do you mean by AC? Alternating current or alternating voltage? Alternating current or alternating voltage. DC means direct current or direct voltage. In DC, the voltage or current strength is constant. In alternating current and voltage, alternating current or voltage, it continuously changes. Look at the waveform here. It continuously changes. So if it is a current form, initially it will be 0, gradually increases. So this is the time axis, reaches the peak, decreases, becomes 0, again increases in the opposite direction, reaches the peak and decreases and becomes 0. That is again repeated. So this is called as alternating, continuously changing. This is direct and this is the alternating. So this is the difference between AC and DC. Fine guys, today we have come across the details of fundamentals of electricity. In the next session, we shall deal with the fundamentals of electronics. Till then, have a nice time.